All right, good day, viewers. I want to be talking about Thevenin's theorem. Thevenin's theorem, yeah, that's on under applied electricity one. So I'm going to be talking about the topic now. I'm going to solve few questions on Thevenin's theorem. So, first thing you need to know about Thevenin's theorem, the first thing you need to know about Thevenin's theorem is that, okay, so we'll have a circuit diagram here. We have a circuit diagram here. So this is a voltage source, as you know. That's the symbol for voltage source. Then these are resistance. So we have two resistance here. How do you identify the Thevenin's resistance, and how do you identify the load resistance? I'm going to show you that for this, we all know this is Thevenin's voltage. So these are two resistance. So you can either take any of them to be as the load resistance or the Thevenin's resistance. For me, I take this to be as the Thevenin's resistance. Then here, I take this to be as the load resistance. So this is the Thevenin's equivalent circuit. So I'm going to solve few examples, but first of all, if you want to solve few examples, I need to let you know some things. some things like some things like when you are given a circuit, you'll be given different sources. For example, if you are given voltage source, you will need to close the voltage source, because when looking for the Thevenin's resistance, you need to close the voltage source. If it is a current source, you need to open the current source. When it is a voltage source, you short circuit it. That's closing the circuit. So let's solve one question here. We have this circuit here, 12 volt. So this is plus, this is minus, and we have a resistance here, 4 ohms resistance. Then we have a 6 ohms resistance here. Then we have a 4 ohms resistance here. Then here is 24 volts, 24 voltage source, 24 volts. Okay, so yeah, how do you go about solving this circuit? How do you go about solving this circuit? You can pause the video and check if you can solve the circuit. First of all, what's the question? Now, this is A, this is B. Now, you are asked to calculate for the current flowing through this 6 ohms. Since you've been told to calculate the current flowing through 6 ohms, that means your load resistance is identified as 6 ohms. Sometimes they will identify it RL, that's the load resistance. But if they don't identify it, they will use letters in between. Some of them, they might indicate them like this. That means you should find the current flowing through 4 ohms resistor. But since it's indicated like this is A, this is B. That means you should find the current flowing through 6 ohms. Understood? So first step, first step is to find the Thevenin's resistance. That's the Thevenin's resistance. Now, how do you go about to find the Thevenin's resistance? Please listen up. If you want to find the Thevenin's resistance, you have to clean off the load resistance. The load resistance is 6 ohms, okay? So let's go ahead. The load resistance is 6 ohms. So I'm going to have here, I'm going to still have here my 12 volt, then my 4 ohms resistance. As I said, you should clean away you should remove the load resistance. So so here you indicate it as RTH, as the the Thevenin's resistance, because we want to find the Thevenin's resistance. So this is still your 4 ohms resistance. Then this is your 24 volt, 24 volt, plus minus, plus minus. Now after you've cleaned away the load resistance, you indicate in that place RTH. What next? Now, as I told you, if it is a voltage source, you short circuit it. If it is a current source, you open it. So the next step, since we have a voltage source, and we are about to find the Thevenin's resistance. We are about to find the Thevenin's resistance. So you close these voltage sources, both the right hand side and the left hand side. So we've closed the voltage source. So we have here RTH. Then this is 4 ohms. 4 ohms here. So we'll also close this side. So now, taking a look at this resistance. Now, we are going to find RTH now. Taking a look at this resistance, what do? They are in parallel, as you can see. So your RTH will be equals to, they are in parallel. So this is 4 times 4 divided by 4 plus 4. So this will give you 16 over 8. So this is 2 ohms. So you've successfully found your RTH. This your RTH is 2 ohms alone. Now what's the next step? The next step is to find your VTH. That's second step. Second step, find VTH. That's the Thevenin's resistance. So you are going to find the Thevenin's resistance. Now, if you want to find the Thevenin's resistance, what do? You come back here. Now, this circuit here, clean this RTH off. We are done looking for the RTH. Now we want to find the VTH. Indicate here VTH. And how do you know the positive side and how do you know the negative side? Now, this current that is flowing here, this current is a positive current, so this is plus. Then this current here is a negative current, so this is an 18, so this will be minus, as we can see. So this is what we will use to find the Thevenin's voltage. Now I'm sure you guys all did nodal analysis, because I'm about to apply nodal analysis in this circuit. So applying nodal analysis, I'll call this I1, I'll call this I2. So I'll call this voltage X. Then I'll call this voltage A. I'll call this voltage C. Okay. So now this current here is entering the node. This is a node. Then this here too is entering the node. Okay. This here is entering the node too. So that's going to be I1 plus I2. According to Kirchhoff's current law, the summation of the voltage in the circuit is going to be equals to 0. So I1 plus I2 equals to what? 0. So now what's going to be your I1? Now let's confirm I1. This voltage is flowing from VA to VX. So that's going to be VA minus VX divided by what? What's the resistance? 4 plus. Now for I2, let's check for I2. This voltage is flowing from VC to VX. So that will be VC minus VX divided by what? Still 4 ohms. Now equals to what? 0. Now let's find out what's VA and VC. Now before we proceed, you should know that VX equals to what? VTH. Or I should have just indicated here VTH at once. So, but you should know that Vx equals to VTH. So now what's your VA? Your VA is 12 volts. So that's 12 minus what? Vx divided by what? 4 plus, what's your VC? Your VC is 24. 24 minus Vx. 24 minus Vx divided by what? 4 equals what? 0. So now let's solve for Vx. Solving for Vx using your algebraic sense. So this will be 3 minus 1 over 4 Vx. So this will be Vx over 4. Then plus 24 divided by 4. 24 divided by 4, that will give us 6. 6 times 4 is 24. So that's plus 6 minus Vx over 4 equals what? 0. So 3 plus 6 is what? 9. So minus Vx over 4 minus Vx over 4. That should give us minus Vx over 2 equals 0. So 9 equals to Vx over 2. So Vx equals to what? 18 voltage. Remember, we're looking for VTH. So recall that VTH equals to Vx. So therefore, your VTH equals to what? 18 volt. Now, that's not all. We're looking for the currents flowing through this load resistance. So we are going to draw the Thevenin's equivalent resistance circuit. So this is going to be, now, look here. We have RTH. This is RTH here. What's your RTH? We already had our RTH. What's our RTH? 2 ohms. RTH is 2 ohms. So the voltage, VTH voltage, that's VTH voltage, Thevenin's voltage is what? 18 volt. Now your load resistance, you already know your load resistance, right? What's your load resistance here? Your load resistance is 6 ohms. So let's impute it here. So what's the next step? Now we can find for the voltage too, but the question here says that we should find for the current flowing through the load resistance. What's the load resistance? This is the load resistance, right? This is the load resistance. Now we are going to apply voltage divider. We are going to apply voltage divider to solve for the voltage here. We are going to solve for the voltage here. So applying voltage divider, that's voltage VL. The VL voltage is going to be equals to what? The VL voltage is going to be equals to 6 times the total voltage. Okay, let me write down the formula first. V total, or VTH times the load resistance divided by RTH, Thevenin's resistance, plus the load resistance. So this is your RTH, and this is your RL. Okay, so finding for voltage across the load. Voltage across the load, you are going to get 18 times 6 divided by 6 plus 2. That's 6 plus 2. That's the RTH plus RL. That's 8. So this is going to give you what? Let me punch in my calculator. 18 times 6. 18 times 6 divided by 8. So I got 13.5 volt. 13.5 voltage. 13.5 voltage as the load voltage. But we were asked to find the current flowing through the load resistance. Yeah, so let's go ahead and find for the current flowing through the load resistance. So since we know the voltage flowing through the load resistance, we are going to apply Ohm's law. Yeah, Ohm's law. So that's going to be I load equals to what? The V load all over the R load. Understood? So the V load equals to 13.5 volts divided by, now, RL. What's RL? 6. So that's 6 ohms. So 13.5 divided by 6. 13.5 divided by 6. And you get 2.25 ampere. 2.25 ampere. Or you can either choose a shortcut. Let's check for the shortcut. That's going to be, if you want to find the load current without wasting time, your load current is going to be the Thevenin's voltage divided by RTH plus RL. So the load current is going to be equals to 18 divided by RTH plus RL is going to give you 6 plus 2, that's 8. So divided by 8. 18 divided by 8. 18 divided by 8 is equals to 2.25 ampere. So as you can see, this and this are the same thing. So I would prefer to use this, but this I was just breaking things down for you. So I'll go ahead and solve the next question. If you have any question, drop on the comment section. I'll go ahead and solve the next question. So for the next question, we have um we have here we have 140 volts, 140 volt. Then we have 20 ohms, 20 ohms. Then we have 6 ohms, 6 ohms. Then we have 10 ohms, 10 ohms. Then we have 90 volts, 90 volts. Okay, so A, B. So the question is that you should calculate for the current flowing through the load resistance. That's the question. And what's the load resistance? The load resistance is 6 ohms. So what's the first step? The first step, you calculate for the Thevenin's resistance. Calculating for the Thevenin's resistance, you are going to bring out this the load resistance. Then since their voltage source, look at their voltage source, you are going to short circuit them. Short circuiting means you should close the circuit. So let's perform that. We want to find R Thevenin, that's Thevenin's resistance. So this will be 20 ohms, 20 ohms. Then we are going to have here R Thevenin's. Then here is what? 10 ohms. Then here you short circuit, as I said. You short circuit this voltage source, as I said. So now we are ready to find RTH. So RTH will be equals to 20 times 10. They are in parallel, as you can see. So 20 times 10 divided by 20 plus 30. Sorry, 20 plus 10. So this is going to give you 200 divided by 30. 200 divided by 30. 200 divided by 30. This will give you 6.667 ohms. So I go with this. So this is your Thevenin's resistance. I go with this. So what are we going to do next? We are going to look for the how do you call it? The Thevenin's voltage. That's the next step. Looking for the Thevenin's voltage. So looking for the Thevenin's voltage, you bring back the voltage in the circuit. Then where you add the Thevenin's resistance, you replace it with Thevenin's voltage. So this is what we are going to do. Let me draw the circuit. So this is 140 volts, 20 ohms. Then see what I was talking about here. You put here VTH instead of Thevenin's resistance. We are done with Thevenin's resistance. So we are about to find Thevenin's voltage. So this is going to be 10 ohms. 10 ohms. Then 90 volts. 90 volts. Plus, minus, plus, minus. So we are going to still apply nodal analysis. So let's call this I1, I2. Then let's call this VTH, okay? Let's call this VB. Let's call this VA. So now, as you can see, the current is flowing into the node. Both I1 and I2, they are flowing into the node. So I1 plus I2, since they are flowing into the node, you add up the current. I1 plus I2 equals what? 0. So what's your I1? Your I1 is going to be this voltage minus this voltage divided by this resistance. So that's going to be 140 minus VTH divided by 20. Then plus, what's your I2? Your I2 is this voltage, because since it's flowing from here to here, it's going to be this minus this. If at to mean this voltage was flowing from here to here, it would have been VTH minus 90. Since it's flowing from here to here, so it's 90 minus VTH. So 90 minus VTH divided by 10 ohms equals 0. So 140 divided by 20, we are going to get that's 7, yeah, 7 minus VTH over what? 20. Then plus 9 minus VTH over what? 10 equals 0. So 9 plus 7 is 16. 16. Then minus, let's type this in. Let's type this and this. So that's going to be minus 1 over 20, then minus 1 over 10. That's minus 3 over 20. So that's minus 3 VTH over what? 20. So equals what? 0. So 16 equals to 3 VTH over 20. So 16 times 20 is what? 16 times 20. 16 times 20. 16 times 20. We'll get 320. So 320 equals what? 3 VTH. So VTH equals to 320 over what? 3. So 320 over 3 is what? So let's get this. 320 divided by 3. So we are going to get 106.667. 106.667 voltage. So we've calculated for the equivalent Thevenin's voltage. So let's draw out equivalent Thevenin circuit. Okay, so let's draw out equivalent Thevenin circuit as I drew. So this is the voltage, Thevenin's voltage. So this is the Thevenin's resistance, and this is the load resistance. So what's our Thevenin's voltage? Our Thevenin's voltage is 106.667 volt. This is our VTH. So RTH, what's your RTH? RTH, we add 6.667. Okay, so what's your R load? Recall you were asked to calculate for the current in the load resistance. So the current in the load resistance, what's the load resistance? 6 ohms. The load resistance is 6 ohms. So how do we go about this? Recall I gave you a simple formula to calculate for the current flowing through the load. That's I load equals to VTH divided by, so this is your R load, RTH plus RL. So IL equals to, what's your VTH? VTH is 106.667 divided by 6.667 plus 6. Okay, so IL is going to be equals to, let me punch that in, 106.667 divided by 6.667 plus 6. So this will give you 8.421 voltage. Current 8.421 ampere. So this is your load current. This is the current flowing through the load resistance. Okay, so we are going to go ahead and solve the last question. So what does the last question say? Let's check. Okay, so I will solve the last question. What does the last question says? 48 volts, 48 volts, 12 kilo ohms, and this is 4 kilo ohms, Then, okay, we have here 8 kilo ohms. Then we have here 5 kilo ohms. So here is indicated RL. So what's the first step? The first step, we are looking for the Thevenin's resistance. Thevenin's resistance. So looking for the Thevenin's resistance, this is a voltage source. You are going to short circuit it. This is a load resistance. So this is a voltage source. You are going to short circuit it. This is the load resistance. Remove it off. Then replace it with Thevenin's resistance. So let's short circuit it. I've short circuited it. So I have here 12 kilo ohms, then 4 kilo ohms, then I include here I include here 8 kilo ohms, then load resistance. We replace it with Thevenin's resistance. So how are we going to solve this circuit? Now this and this are in what? Parallel. This is in series with them. So let's solve for our parallel first. Our parallel is going to be equals to 12 times 4 divided by 12 plus 4. So this is going to be 48 divided by 16. So 48 divided by 16, 3. So this is 3 ohms. So this is 3 ohms. So combine it with this, we'll get our Thevenin's resistance. Thevenin resistance is going to be equals to, so this is 3 kilo ohms. So Thevenin's resistance is going to be equals to 8 plus 3. So that's going to be 11 kilo ohms. Okay. So we've gotten our Thevenin's resistance. These are Thevenin's resistance. So let's go ahead and calculate for the Thevenin's voltage. Calculating for the Thevenin's voltage, you will bring back the voltage source, then replace this place with Thevenin's voltage. So let's go ahead and do that. So we are going to get in the circuit 48 volt, then 12. Okay, I forgot something. The question says that you should calculate for the current flowing through 5 kilo ohms. So that's the step we are moving to. We want to calculate for the current flowing through 5 kilo ohms. So let's go ahead and calculate our Thevenin's voltage. 12 kilo ohms. Then this is 4 kilo ohms. 4 kilo ohms. So this is 8 kilo ohms. Then this is your Thevenin's voltage. Okay, this one here is very simple. We are just going to apply voltage divider alone. That's, voltage divider works in a series circuit. Understood? So where do we find a series circuit here? This is a series circuit. So we are going to use this circuit here to find our VTH. Understood? So what's the resistance, the opposite resistance facing VTH? Is 4, right? So our VTH will be equals to the total voltage 48 times what? 4. Okay? Divided by, if it was 12 kilo ohms facing here, it would have been times 12, but this is 4 here. So it's focused on the opposite resistance. Understood? It's focused on the opposite resistance. You cannot say 48 times 12. Okay, it won't work that way. We are looking for the Thevenin's voltage. If you go and do here times 12, that means you are looking for the voltage flowing through here. Understood? So 48 times 12 divided by 4 plus 12. So this will give you, this is going to give you 48 times 4 divided by 4 plus 12. So this is 12. So the Thevenin's voltage is just 12 volts. So let's draw a equivalent Thevenin circuit. So Thevenin's voltage 12 volts, then your R Thevenin's, that's going to be 11 kilo ohms. 11 kilo ohms. Then what else? The load resistance. The load resistance, This is your RTH, the load resistance. The load resistance is 5 kilo ohms. 5 kilo ohms. So how do you go about calculating? I gave you a simple formula. So your IL is going to be VTH divided by VTH divided by VTH divided by RTH plus RL. So this is going to be equals to 12 divided by RTH. That's 11 plus 5 kilo ohms. So 12 divided by 11 plus 5. So this is going to give us 0.75 ampere. So please, if you don't have a basic background for circuit analysis like the simple ones like the nodal analysis, the superposition, Kirchhoff's current law, Kirchhoff's voltage law, please endeavor to learn. If you don't understand those basic ones, you can't understand this. Please note that for those that learned nodal analysis, superposition, all those simple basic ones, Kirchhoff's voltage law, Kirchhoff's current law, they can understand this. Please do so to learn. Thank you. Please subscribe to my YouTube channel.